All right, this is lecture 23, example problem 1. We're asked to find the moment of inertia of a rectangle that is placed 9 feet above the x-axis, and we're asked to find the moment of inertia about the x-axis. Right, so the first thing we need to do for this is we need to find the moment of inertia for the rectangle about its centroidal axis. So the centroidal axis is that dashed line, right? So that's our initial x-bar centroid axis. So if we're trying to decide, we've got 4 feet and we've got 16 feet. Which one's the base? Which one's the height? So when we're doing moments of inertia, areas that are further away from the axis of rotation contribute more to your moment of inertia. So the dimension that has this cubed factor has to be the dimension that's pushing your area further away from your axis of rotation. So in this case, that would be 4 feet, right? So that 4 feet is going to be what we're going to use for our height, and the 16 feet will be what we'll use for our base. So we go ahead and plug in 16 feet times 4 feet to the third power all over 12 gives us 85.3 feet to the fourth. So that's our moment of inertia about the centroidal x-axis. However, the problem asks us to find the moment of inertia about the actual x-axis as drawn on the figure. So to do that, we need to use the parallel axis theorem. The moment of inertia about the x-axis is equal to the moment of inertia about the centroidal x-axis plus the area times the distance that the axis of rotation has been shifted. So finding the area of the rectangle is pretty easily. Base times height, 16 feet times 4 feet gives us 64 feet squared. And then the distance that we're shifting our axis, we're starting with a centroidal axis that's 9 feet above the x-axis. The x-axis itself, 9 feet below that. The distance of our shift is 9 feet. So we go ahead and plug in 85.3 feet to the fourth plus 64 feet squared times 9 feet squared is equal to 5,269.3 feet to the fourth. And at this point, we have our moment of inertia about the x-axis.